Well, this is the Mark Tovar design wooden clock that I decided to build about 6 months ago, and I found after 6 months of frustration that it was probably a design flaw in this particular clock. Firstly, I got the design out of a book called Wooden Clocks, which I bought over the internet for in excess of $30, and unfortunately for starters the book had left two important diagrams out. So I had to send to the publisher and they emailed me back the correct diagrams. So that didn't get us off to a very good start with this clock. Over that 6 months, I've remade a lot of the gears. I've eventually remade the rings that actually support the clock. There's a front and a back ring, and I learnt from that one that you actually have to take the two of them together and drill them together so that the shafts or the arbors or axles, whatever you'd like to call them, actually line up. So that happened fairly recently. But the other thing, probably the thing that got the thing going, was an actual change in the design. First of all, where the great wheel is down the bottom of the clock, as you can see, what I had to do there was make the drum, and that's the drum that holds the fishing line which supports the weight. I had to make that bigger. I figured by doing that, that would give more energy to the clock. On top of that, I incorporated a Clayton Boyer design for the escape wheel. Now the escape wheel from one of his plans is really exactly the same as the original escape wheel, but it's bigger and it is also thicker, whereas in the original plan it was made of 1/8 ply. I made it now out of 1/4 inch ply. But the real breakthrough came with the pallets, and when we have a look a bit closer later on, you'll see that, and this once again came from a YouTube exercise, and a friend had pointed me towards that direction. The pallets on YouTube was once again one of Clayton Boyer's designs, had little teeth on it that you could take out and put back in again, removable teeth. Now the idea of course is that instead of having to build new pallets every time you get it wrong, and that by the way is about the 6th set of pallets that I'd built, now I can just put adjustable teeth in there. And I worked on about 12 sets of teeth over a week and finally got it right. And so the other thing that needed to make it run was an increased weight. Now that can often have to do with the amount of friction that is in the clock itself, but the original weight in the American book was 3 pounds. This weight now is 4 pounds. And the clock runs continuously. It has to be rewound about every 12 hours and now hasn't stopped for nearly 2 weeks. So I figure that we finally got it right, and I think those things, those differences those things that I put in there made the difference in getting this clock to operate. So we'll move a bit closer and you can see then the adjustable teeth in the pallets. So here we have the great wheel, and as we move in closer, here we can see the drum, and it is certainly considerably bigger. It's 43 millimeters in diameter and considerably bigger than what is shown in the original plan. The energy there, extra energy there, plus the extra weight, transfers that energy to the second wheel, then to the third wheel, and you can see the escape wheel moving here, but more importantly you can see these adjustable teeth. And I believe that makes the difference, because you only have to build one set of pallets and just make the teeth adjustable to suit your particular escape wheel. Now I've looked on YouTube and I haven't been able to find any other version of this clock that was really working. There was one on YouTube where somebody was obviously moving the pendulum every minute or so, but this is the first one I've seen working, and I hope that those few tips work for anybody else that wants to build this particular clock.